Hello everybody. Today we'll be doing a algorithm called look and say. The look and say sequence is defined as following. Beginning with the term 1, each subsequent term visually describes the digit appearing in the previous term. The first few terms are as follows. So 1 would be 1. The second item would be there is 1, 1. So in this third item, it will be like, oh, there are 2 ones. So each item is built on the previous item. So this means that we will need to do build up the string n times. For each time, we need to read until the end of the string. And count the consecutive terms. Then we repeat that process building string upon non-consecutive term. And once we've hit the end of this cycle, we can return our answer. So there are some ways that this can be helped. If we use the group by function on S, we could count the consecutive items, and that way speed this entirety coding process up. So let's start with the sped up version, and we will go into the longer version. So first of all, we'll start our string off at 1. And for I in range 1 all the way until n, we will set our temp string to be equal to empty string. We're going to be building this string up. So for x and y in group by, we're going to say temp is going to plus equals. We're building up the string length of list y plus x, which is the item in question. So then once it's all built up, s is equal to temp, and once that's all done, return s. Run. Looks like there is an issue here. It's temp s. Perfect. Why is there printing going on? Oh, 40. That's why. So that's it. Looks like there's a lot of functions going on here. We created a list and everything. That's an O of n operation and everything. We can reduce this to O of 1 space rather than the O of n space that we're using. Also, this is n squared times because we have to go through the entire range, and for each entire range we're gonna have to go through that entire string and group them. We're gonna still use the same like n squared time, but we're gonna bring down the space to 1 now. Alright, so repeating the same thing more or less. We're going to replace this by saying the previous item is here, and we're going to count the consecutives. We also want to bring this down so that we have a little bit more space to type. Okay. So for each character in the string, we're going to count what number of previous items, count the consecutive items. So if previous is currently empty, so previous is equal to the current character, and consecutive counts is equal to 1. We could also skip that one by doing this. So previous is equal to s of 0, and this is going to start from 1 onward. And we can skip this entirely. So just say if character is equal to previous, consecutive count plus equals 1. Otherwise, we're going to build the string now, not consecutive anymore. So temp string is plus equal the format of the consecutive count and the previous number item. Then the previous is going to be the current character, and consecutive is now reset to 1. Once this is complete, we're going to set, we have to do this one more time, because once we've hit the end of our string, there is no item that we're counting anymore. So if it is equal to the previous, then we still have to add it. If it is not equal to the previous, we also still have to add it. So in either case, we have to add this to the end of our temp string. And once we do so, we set s to be equal to our temp string. Once this is complete, we can return s. So let's run. Timeline exceeded for some reason. That's not right. Something's wrong. I see. So this structure here is not working. Trying to save this because the way we cut the string. So let's just go back to our previous selection. So previous equals char, and consecutive count is equal to 1. Previous is equal to blank, and consecutive count is equal to 0. Alright, so let's try that again. Timeline exceeded again. What could be the issue here? I'm not sure. Give me a moment. I'm not sure what's wrong. Why is it taking so long? There's a timeline exceeded problem here, and I'm not sure why it's not working right now. Hmm. Weird. Anyways, this is the solution for, let's say, a that we have that is workable. It does run in out of um, one space because we no longer have to keep a list. But it seems that we are getting a timeout. Oh, I see. I see. There we go. That was the problem. Looks like there was a error in the count. But this is the way we do it of one space and n squared time. It's looks like it's slightly faster because there's less compute in creating the list and everything. So that's all for today's problem. If you have any questions, please comment below. If you like the video, please like it. And if you like more videos, please subscribe. There is also a link in the description below where you can find more of my algorithms and iOS development. Thank you very much. Have a good one.